Well, we're the information advantage company. One thing that we do understand in the warfighting space these days is that we can no longer roam the underseas with impunity. There are areas that are much more difficult to get into, that are denied access completely, or where threats exist. So what we wanted to do was address that problem, the problem of target identification and ship identification from a standoff distance, to keep our ships and our boats safe, and to avoid detection while, it's the age-old problem, identifying the target before they identify you and tracking them in a logical manner.
At Rite-Solutions, we had the idea that we wanted to have a proof of concept demonstration of some of the technologies that are necessary to identify and classify ships. The key technology that we're really talking about here is artificial intelligence. More specifically, it's machine learning. We had trained machine learning models with ship's images to identify and classify them in a variety of circumstances, situations. And we were very successful in doing that. Now what we really want to do is we want to put that in the water. And so the concept is, in collaboration with the University of Massachusetts at Dartmouth, we put together a buoy. And the buoy consisted of cameras and some additional hardware. And what this really is what they call computing at the edge, or edge computing.
The buoy is a waterproof enclosure that we needed to withstand reliably 10 feet or more of water pressure. And essentially it houses a bunch of different sensors that we use to tell kind of what's around us in the ocean. Right now we have cameras that will essentially accomplish the task of being able to view the world in 360 degrees, and then we can pass those images through our Raspberry Pi, which is kind of our main computing unit of the buoy. We wanted to gather additional information of where we are in the world to be able to tell where these things are in relation to the buoy. We accomplished that through the use of a GPS and IMU module. So we can tell where we are, but also what the orientation of the buoy is at that time.
What we have on the buoy itself are 3 cameras that give us a 360-degree view of the world. Those cameras are producing images. Those images go into our machine learning model. The key thing here is that once we transmit that information, you can go back to either a workstation that may be on a platform at sea or on shore. So the concept here is we are not continually streaming data over the communications network that we have, but rather we're doing it in bursts. When we find something that's of importance, that's when we will transmit that information.
And then that essentially just plots that information onto a map interface with just map markers. And then we also have kind of a visualization of the view from the buoy where this object is. And we can also track the location of the buoy over time, even if we don't see anything. So we do that through kind of just a red line that tracks where we are.
The multiple use factors associated with this solution are myriad. You can do all kinds of things with a solution like this because of the flexible architecture involved. So for example, you could put the buoy or the detection system on a pier, in a harbor, along a coastline, or field it from a Coast Guard vessel engaged in search and rescue missions. We're a company dedicated to providing our warfighters an information advantage, and we do that in numerous ways. We're always on the lookout for finding new ways to provide information that'll give an advantage to our customers, and in particular our warfighters, faster, better, and cheaper. That's what we're constantly trying to do.